Exactly. The initial is always when x is or t is 0. So we have the concentration. This is the function, and all we are asked to find for initial dosage, it's C of 0.
So 42.03.
Exactly, because when t is 0, e to 0 becomes 1, so it's 42.03. Please never forget the measurement unit, micrograms per milliliter. Let's see what they want in part B. What is the average amount of phenylbutazone in the calf's body for the time between 10 and 120 hours? Average 10, 120. How do I determine the average dosage? Between 10 hours and 120 hours from the initial, of course. How do I do that?
So 1 divided by 120.
Yes, 120 minus 10. Yep. So the C average on 10 to 120 will be 1 over 120 minus 10. The integral from 10 to 120 from that ugly thing. I don't need the last 0. Did I copy? Yeah, there is no need for last 0. Good. So 120 minus 10 is minus 10 is 110. Please keep an eye on my numbers. Of course, I will take out this number because it's a factor. So 42.03. The integral from 10 to 120 from e to negative 0.0105 t, of course, dt. Good. So I copy 42.03 over 110. And now, which function prime is e to negative 0.0105 t? Okay, let me refresh your memory. So e to the x, the integral from e to the x dx is e to the x. Of course, plus a constant c. That's the general, the indefinite integral. But the integral from e to ax dx will be e to ax over a plus a constant c. Whatever this number is, it doesn't matter.
So it's just e to the negative 0.0105 t divided by negative 0.0105.
Yes, that's it. Perfect. Perfect. Good. So this and this and this are out. So 42.03 with minus in front. And this times this. I'm not going to multiply it. I'm going to multiply once at the very end. So now, when I plug in 120, e to negative 0.0105 times 120, but minus when I replace t by 10. So negative 0.0105 times 10. So here is how we enter it. Careful. So here I will have parentheses, but I will also have parentheses around the denominator. So I have a set like this and a set like this. Otherwise, the calculator may calculate something else. Careful. I will have parentheses around the exponent because that's me. It may not need it, but this is what I'm going to put. Parentheses around the whole fraction in front, negative, parentheses around the denominator, because if you don't put parentheses, the calculator will divide by this, but then multiply by this instead of dividing by it. Careful. And all this as you see it. So parentheses, negative 42.03, and divide by, parentheses, 110 times 0.0105. If you do it piece by piece, you will introduce a lot of error. That's why I don't recommend you put it piece by piece. Okay, so now E, and the power is negative 0.0105, negative 10105, I think I have it, times 120, close the parenthesis, come down from the power, if you have this kind of calculator, and minus E to negative 0.0105 times 10. Yes, that part I can do it by hand, but I didn't. Okay, and come down, put parenthesis, close the parenthesis for the this one, the pair, and when I press enter, I get 22.44, and it's the average, and it has to have the same measurement unit. It was in micrograms per milliliter. Micrograms per milliliter. Yes, you can check the answer with the whole thing. Don't forget to put in front, insert. What do I want to insert? I want to insert 1 divided by 110. 1 divided by 110. And then I have the integral from 10 to 120. No, not that far. Easy. 120. Okay, dx. And now I'm struggling with this ugly function. Okay, 42.03. And then e raised to negative 0.0105, and of course x, and click enter, and I expect 22.44. It better be, because I had my share of miscalculations today for the next 10 months. So it is 22.44. How do you feel about this? Do we have any questions?
Professor, I have one question.
Yeah, any question, please. Ryan, go ahead.
So, if this was a test per se,
yes,
and we wanted to write the answer, would we just put the average of 0 to 1, or from 10 to 120 is equal to 22.44?
So here's the answer. Very good question. So I want you to show this.
Yeah.
I want you to show this. You don't have to show this.
Okay.
And you can put the answer.
Okay.
I will have to assume that you know to plug in 120 and then subtract 10. So also on the previous problem, so if you just write this, you can write this and you can skip the calculations and put the answer. But I want to make sure that my students show that they plug in 4, and then when they subtract, when they plug in 0, they get 0. So yes, you can skip the arithmetic calculations. I mean, we had some on the study group today. Look at this, right? And that was a different problem. So I don't want my students to spend time. I spend time on the arithmetic, and I still made an error here. I wrote 40 instead of 32. So once you plug it in after this, I don't want you to calculate. Just put the answer if you have that kind of calculator. Good. How are we feeling about this now? Is it better? Can we continue? Any questions? Are we okay? Okay, so let's finish then chapter 4 with 4.5, substitution rule. This is a technique of integration. It's a technique of integration. There are many techniques of integration. In this class, we only discuss one, the simplest one, which is substitution rule. Before we start, before I show you the technique and before we look at examples, I want us to choose a function. Give me any function you want. And I would like to discuss for a moment the derivative and the differential. So make up any function you want.
So minus 2x squared minus 6x plus 8.
Excellent. Good. So now for this function, let's find the derivative. Can anyone help with the derivative?
Minus 4x minus 6.
Excellent. Now, can anyone give us the differential of the same function? Anyone? It's okay if you're wrong. We have to discuss this because this is very important. Are they the same? Anyone? Okay, please remember, this is dy, and this is f prime of x dx, which means dy equals negative 4x minus 6 dx. So this is extremely important to understand the difference between the derivative of a function and its differential of the same function. The derivative of the function, the differential of the function, which by definition is f prime of x dx. F prime of x dx. Why is this so important? For the substitution rule. Okay, so I'm just going to illustrate with one example, with many examples, but I just want to start working on one. So I'm on page 434. Please choose. I'll let you choose anything you want from 1 to 74, but after I show the first two examples, and then you can choose anything you want. So I would like to start with number 3. And we have the integral from x squared minus 6 to the 7th power times x dx. Okay, so we're going to look at the substitution rule for indefinite and definite integrals. So we're looking at indefinite first and then definite. Indefinite do not have limits of integration. Definite have limits of integration. The first one is a function, the second one is a number. Okay, so I'm looking at this function. So I have whatever, the x, of course, because the variable is x. And I see that this function is a product of two functions. How come? Yeah, I see x squared minus 6 to the 7th power, and then multiplied by x. Obviously, I cannot do anything to this x. But I'm looking at this. It has power 7. I'm not going to expand. If this had power 2, I would have expanded and multiplied by x and then done. But in this case, I'm not going to do it because this is power 7. I could, but it would take me like forever because of power 7. So I say to myself, okay, is there anything I can do to this expression so that the entire product is easier to work with? And I'm going to say, okay, what if I say give me any letter, not x, any letter you want to work with, it doesn't matter, but not x.
H.
Very good. Let h be x squared minus 6. So careful, we created a new function. We denoted or called this function h, or if you want, h of x. But I really need a letter, but it's h of x actually. Good. So now can you determine for me dh, the differential of h? Keep in mind what the differential means. Can anyone give us the differential of this function? I have to find the derivative first, which is
2x.
very good. And I have to multiply it. If it's x, I have to multiply it by
D of x.
dx. Perfect. Okay, so then let's see if dh is in our problem. I see the x. I see the dx. Well, I only have a minor situation with the 2. Not a problem. Here's what I'm going to do. I am going to multiply by 2 and divide by 2. What does this mean? Nothing. 2 divided by 2 is 1. I didn't make any change. However, 2 and x and dx, don't cross it out, no, don't do anything like this, but I just want to make a point. All these 3, 1, 2, 3, will be replaced by dh. The 1/2 will go in front, because there is a 1/2 left in here. And please tell me, what do I replace this by? I know that this piece is dh. But what do I replace x squared minus 6 to the 7th power by?
Is it h to the 7th?
That's it. That's it. Notice one thing. This integral had x in it. This one can no longer have x. I cannot have h and x at the same time. So if this integral has x, and I found a substitution, I found the dh of the substitution, then everything I have here changes into this. And the number doesn't matter. It's just a tiny number. So now this is so much easier to integrate because I have a 1/2. I know what to do with this, h to the 8th power over 8 plus a constant c. Because it's in an indefinite integral, I have to have the constant. So all I have to do now is go back to my substitution because I have to give the answer in x. This was our tool to get to the answer. But the final answer has to be presented in x. So then the final answer will be 1 over 16 1 over 16 in parentheses x squared minus 6 to the power 8 plus a constant c, and it's done. So before we choose the next and the next and the next example,